So we have started our CCNA training program in the previous session. In previous session, we just discussed about introduction to CCNA and Cisco certification tracks and the levels of training program, which is entry level, associate level, professional level, expert level, and architect level. So now we are in CCNA level. Like in CCNA level, like what type of technologies, what type of tracks we have, routing and switching track and security, wireless, all the different tracks we discussed. And in our training, we are going to cover up like a routing and switching, security, wireless, voice, these all the things in basic level. The mainly routing and switching part actually, plus Cisco security. This is our training and device schedules we have discussed. So later on some network fundamentals is started, like we discussed about what is a network and what is networking, internetworking, types of networks, and roles and responsibilities of a network engineer in the real time, and basic requirements to form a network in that NIC, media, networking devices, logical address, and protocols. So I'm asking to everyone, do you have any doubts regarding the yesterday topic? Like whatever we have discussed in the previous session, if you have any doubts, you can ask. Yes, please. Okay, all right. So let me start today with NIC. Network Interface Card. NIC stands for what? It's a Network Interface Card. So what is the purpose of this NIC? What's the use of it? This NIC card, we can call it is a Ethernet port, RJ45 port, LAN port, right? So the different names is there. So what is the use of it?
It is used to connect devices to computer network.
Very good. Okay. Yeah, computers works with operating system, right? If there is no OS, can you work with the computers? No, not possible. Then what is the use of OS operating system? Like computer, generally we used to connect a keyboard, mouse, hard disk drive, pen drive. So these all are hardware components. As a user, how we can utilize these hardware components, how to work with the hardware components, how to interact with the hardware components. So user can interact with hardware components through operating system. So there is no direct interaction between the user and hardware component. So you want to use any hardware component, like it can be a mouse, it can be a keyboard, it can be a hard disk, any like any pen drive, like any hardware component you want to use it, like it possible through via operating system. So operating system is an interface between the user to interact with hardware components. It's acting like an interface, guys. Operating system is what? User interface between the hardware components, the user. Similarly, what is the purpose of NIC is a, it is also, what is I? NI? I means what? It's an interface. So interface for what? OS is interface between the user to interact with hardware components. Now what about your, this NIC card is also an interface. Interface for what? It's the interface card between network. It's a network interface. Network means we know. So yesterday we clearly discussed what is network. Interconnection of two or more devices. Like to interconnect two or more devices, we require interface actually. No? So it's a interface to form a network. This NIC, like without operating system, we cannot work with the computer. Similarly, without NIC card, we cannot form a network. So this NIC card we have a two addresses. One is MAC address, media access control address. Another one is a IP address. So we'll see later about IP address. First, we'll see focus on MAC address. The MAC address is, we can call it is a physical address, or we can call it is a hardware address. Two names, physical address or we can call hardware address. This MAC address is 48-bit MAC address. 48 bits means what? 01, 01, 11, 00, 0, 0, 1, like the combination of zeros and ones, like 48 bits. 48-bit MAC address represent with 12 hexadecimal digits. Like hexadecimal means what? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 it's A, 11 it's B, so let's see, 13 D, 14 E, 15 F. So 0 to 9 is the decimal numbers, A to F, a combination of hexadecimals. So hexadecimal is a combination of 0 to 9 and A to F. So MAC address is a hexadecimal format, guys. For example of MAC address, like 0 to A9, 0, 0, C, D, E, F, something like that. 1, 2, 3, 4, 5, two more. 8C, like this. This is the MAC address. Like how many hexadecimals? 12 hexadecimals. Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's an example of hexadecimal, right? Then, then how we can check our computer MAC addresses? Like for every computer, we have an NIC card. So for NIC card, we have the MAC address, right? How we can check that? Like open your command prompt and you can use get MAC command, enter. So here you can get, say, physical address, or we can call the hardware address, right? Say example of MAC address. This is my computer MAC address. The MAC address is 48-bit MAC address, divided into two parts. First 24 bits and second 24 bits. So what is the first 24 bits means? Like manufacturer ID. So this NIC card, which company has been manufactured? Like Intel is manufactured, HP is manufactured. Like which company has been manufactured? Like manufacturer ID indicates first 24 bits. So technically we call it is a OUI, Organizational Unique Identifier. And second 24 bits is a serial number of NIC card. It's a serial number. Like in this example, first 24 bit means D4, BE, D9. This is first 24 bits. So this indicates OUI, Organizational Unique Identifier, like which organization has been manufactured. And second 24 bits is a serial number of an IC. Okay, guys. Yeah. This is the structure of unicast Ethernet address. First 24 bits, size in bits, 24 bits. What we call this is OUI, Organizationally Unique Identifier. Second 24 bits, vendor assigned, like serial numbers we can say. So 24 in bits, 6 hexadecimal digits. Example is this. Okay. Is it clear about NIC card? Yeah. Now, this is my computer. For every computer by default, we'll get Ethernet port, right? I mean NIC card. Let's say this NIC is my Ethernet port. This Ethernet can support 10 Mbps speed maximum. 10 Mbps speed for this computer, right? Now I required internet for this my PC. I have contact to my service provider, internet service provider. So ISP will give one internet cable, internet link. That link I connect to my computer. Not directly, between we have routers or this available. Okay. Now I'm paying for 500 rupees. Just for example, I'm telling guys. So I'm paying some amount for ISP, and ISP is giving 5 Mbps speed. My internet link speed is what? 5 Mbps. Okay. Now NAC card can support 10 Mbps. ISP is providing 5 Mbps. Like how much speed I can get internet? 5 Mbps or 10 Mbps or 5 plus 10, 15 Mbps. How much speed we can get internet, guys? Yes, please.
Max
10
5
Mbps we can
Mbps.
get. It's just
Around
5 Mbps only now.
yes, only fine.
Yeah, how much your NIC can support 10 Mbps up to 10 Mbps, but ISP is allowing you to reach internet with 5 Mbps only, right? So we can get 5 Mbps only speed. Okay, like 5 Mbps is not a sufficient speed nowadays, and I'm paying some. I'm changing my plan, internet plan. I'm paying 1,000 rupees, and ISP is giving 10 Mbps speed. Now, how much speed I can reach internet? 10 Mbps or 10 plus 10, 20 Mbps.
10 Mbps.
Perfect. 10 Mbps only. Right, Rahul. Okay. Now, the point is, I have installed in my computer some high-speed applications like a VMware's virtual machines I'm installed, and or maybe I'm a web developer, like a web designer, like I have installed some web applications also, or maybe I'm a movie makers, like movie maker, like animations things we have installed. Some very high-speed applications I'm running in my computer, guys, like online gaming developers. So very high-speed application are running. Now, internet speed is not a sufficient, and I'm paying for 9,000 rupees for service provider. 90 Mbps I'm getting now from service provider. Now, how much speed I can reach internet? 90 Mbps or 100 Mbps?
90.
How we can get 90 Mbps?
It's
10
10
M
Mbps.
10 Mbps.
It's 10 Mbps only. Yes. Because of maximum your NAC card can support 10 Mbps only. Even ISP is allowing you to reach the internet with 90 Mbps also. But your NAC card maximum is supporting 10 Mbps. But you are paying 9,000, and ISP is giving 90 Mbps, but still we can use 10 Mbps only. Then how we can get 90 Mbps speed? How we can utilize the 90 Mbps speed? So we have to change your computer now, right? No, we just upgrade your NIC card. Like we have one more type of NIC, so which we call the fast Ethernet. So if you replace Ethernet port into fast Ethernet port, this fast Ethernet can support up to 100 Mbps. If you're supporting 100 Mbps means ISP is allowing you like 90 Mbps, then you can utilize the complete 90 Mbps speed. So not only fast Ethernet, like one more type of Ethernet port, which is gigabit Ethernet. Gigabit Ethernet. So this gigabit Ethernet can support 1000 Mbps, or we can call 1 Gbps. So these all are types of NIC cards. Network cards are available in different speed, Ethernet, fast Ethernet, gigabit Ethernet, and its speeds. Clear? And I have a quick question to everyone, like a very simple question, guys. So how long you used to work with the computers? General question. From how long we are using computers, guys? 5 years, 10 years, 15 years? I mean, asking yours. So you, how long you're working with your computers, guys?
3 years.
10 years.
Okay.
Yes.
Let's take a common 10 years. So because of we are done your graduations and we are working with the so working guys everything. Right. So from past 10 years we used to work with the computers. So have you ever verified your computer has which type of NIC card? Is it Ethernet port or fast Ethernet or gigabit Ethernet? Your laptop, your personal device is supporting for 10 Mbps or 100 Mbps or 1000 Mbps speed. Have you ever verified, guys? No. Generally, we don't check actually. No, why? Because like today we have started our training on the internet, like a network engineer, like a CCNA training, right? So even before we don't require. So we are getting internet cable and connecting to your Ethernet ports, enter your internet password, that's it. But we didn't concentrate in the back end, what are the components is there. So this is very, very important logic, guys, actually, So at least, so everyone, I hope everyone has a personal device, right? So at least your devices, how much speed it is support. Your laptop has a Ethernet port or fast Ethernet port or gigabit port. So let me show you how to check the NIC and NSC speed. Step one, press Windows R key. Windows R key, then you can get this. Yeah, you can get this run box. And here you can type ncpa.cpl. Yeah, ncpa.cpl. Enter, and we can get network connections. So control panel, network and internet, network connections. This is Ethernet adapters. So here, right click on Ethernet. Then you can get properties. The right side top, configure. Second option, advanced. And here we have speed and duplex. The right side value. So my laptop can support 10 Mbps, 100 Mbps, and 1 Gbps full duplex. So it's a gigabit Ethernet. The same manner, you can check for your computers, guys.
And Balu, there is half duplex and full duplex. What does it mean?
Yeah. So what is the half duplex and full duplex is a type of communications from your data exchange can done in the three ways. In network, data exchange can possibly the three ways, guys. So that is simplex communication, half duplex, or full duplex. There are three ways to data exchange. You want to exchange the data to devices, three manners: simplex, half duplex, full duplex. What is simplex communication? Like one-way communication is simplex. The best example is a TV stations. From TV station, your TVs are connected, right? So from TV station, the signals will come to TV and it will give the output. Means a TV always will receive the signals only. A TV, from TV can generate the signals to TV station? No. So means only one way. From TV station will get receive the signals. That's it. So that is simplex communication. Same like a radio stations also. From radio station to your radios, we'll get the signals, receiving signals, and we can get communicate. From radio, can we generate the signals to radio station? No. So this type of communication we call simplex communication, which is only one way. Then what is half duplex communication? Like half duplex communication means from your computer, we can send the data to another computer. Yes, yes, we can send the data, right? When another computer is sending, can we receive? Yes, we can receive also. But sending the data, receiving the data at the same time is not possible. So simultaneously is not possible in half duplex communication. If it's a half duplex communication, either we can send data, either we can receive the data. So simultaneously you cannot send the data and receive the data actually. If you forcefully do that, then data has been collapse. The best example of half duplex communication is the walkie-talkies, the well-known example. The walkie-talkies either you can send the signals, either you can send it or you can receive it, right? So means your NIC card, your PC NIC card can support half duplex communication also, full duplex communication also. So here showing is what? 10 Mbps half duplex. If you choose it, if I click on it, if you press OK, then my PC NIC card can support only 10 Mbps half duplex communication only. Means either you can send or either you can receive it with 10 Mbps speed. Or if I forcefully entered 100 Mbps full duplex, so same time I can send and receive the signals with 100 Mbps speed. Okay, so by default here auto negotiation is there actually. Means other person is sending a half duplex, it can accept for half duplex also. Other device sending a full duplex communication, it can be accepted because of here it had configured what? Auto negotiation. So simplex is one-way communication. Half duplex is either you can transmit, either you can receive. Simultaneously is not possible. And full duplex, yes. So sending and receiving simultaneously is possible. Actually. It's clear? Right. So these all are NIC and NIC types. NIC cards are available in different speeds. So is all about NIC. Any doubts about NIC card, guys?
No, Balu.
Yeah. Point number one we have done about NIC. Next point is a media. Media have a two categories. One is guided media and unguided media. Guided media means it's a wide, unguided is a wireless. Unguided, there is no proper guidance because of how the signals will pass on. We cannot say exactly, right? In the wireless, like if you are here, you can get maybe signals. If you move around somewhere, maybe signal will be drop. So certain direction, you can get the full signals. In certain direction, maybe signal will be dropping. So there is no proper guidance for wireless actually. It's unguided media. But wide is what? Guided. Like all the data must pass through the wide, the section of wide, right? So proper guidance is there. All the data should go via wide. Guided. In guided, we have a different type of cables, which is coaxial cable, twisted pair cable, fiber, optical fiber cable. So these are the different types of. In twisted pair, unshielded twisted pair and shielded twisted pair, and unguided infrared waves, which is the Bluetooth signals, radio frequency waves, which is the Wi-Fi signals, right? The coaxial cable. Have you seen the coaxial cable? Yeah, this is the coaxial cable. So generally, where we use this type of cables, guys?
But TV connection.
TV connection, right? Yes, exactly. So, but early days, like olden days, we use this coaxial cable for internet purpose also, data communication also. But now we're not enough because early days we used actually. So these cables will support very low speed data transmission, even half duplex. No? So that is why we are not making use this type of cables no more for internet connectivity or data transmission. This is using only for what? Simplex communication only, which is television. That's it. So these are outdated for network and data transmission. We don't use these cables. Then most commonly used, the next point is fiber cables, optical fiber cables. Optical fiber cable, there are different type of cables is there. Single mode, dual mode, different type of cables in the optical fiber cable. Mostly service providers will be use it for long distance and very high speed internet connectivities. The long distance like kilometers, one state and different countries, the submarines under the sea, under the earth, like optical fiber cables mostly used for service provider network. Like if you are working for service provider and if you want to work with a like optical fiber cable team, optical fiber team, then we require a very good knowledge on optical fiber and cabling part. But we are going for the network operations, right? So that is our target is different. So we don't require the much detailed knowledge on optical fiber cable. So even only for optical fiber cable, there is a separate training program is there for optical fiber cable. This is a diploma course is there. Okay. So the special interested, if you want to work, understand about optical fiber cable, that is a different course. So our main target is what? So we are going to start our career in network operation sites. So we require the network devices, the network protocols and configurations, those things actually. So coaxial cable is not required. Optical fiber cable, just to understanding is okay. But most commonly used cable is twisted pair. Twisted pair cable. Twisted pair. Two types of twisted pair. One is a single pair and four pair. So single pair means two wires, one for transmission, one for receiving. TX and RX. Transmission the data, is in the data. So with the first wire, all data is being transmitted. In the second wire, data is being received. But where we use the single pair cable, as per IEEE standards, single pair which we called RJ11. Four pair cables is RJ45 cable. RJ11 cables are used in telephone lines. Telephone line, if you see the wire, that is a single pair, two wires will be there actually, telephone line purpose. Then where we use RJ45 cables, like RJ45 cables used for your local networks. Yesterday we discussed one office building here, ground floor, first floor, there are 350 devices. Now, to interconnect all 350 devices, like what type of cable we have to use, guys? RJ11 cables or RJ45 cable?
Okay, 45.
RJ45 cable. So in RJ45 cable, again, we have different type of categories. which is Cat 5. Cat 5 means what? Category 5. And Cat 5e and Cat 6. What is the difference between this Cat 5, Cat 5e, and Cat 6 is a data transmission rate, which we call DTR. Data transmission rate means the data is being transmitted, how much speed. If it's a Cat 5 cable, the data transmission rate is 100 Mbps for Cat 5 cables. Cat 5e cables it can support 500 Mbps speed. If it's Cat 6, 1000 Mbps. So these are the different type of categories in RJ45. These all categories comes under RJ45 ports, RJ45 types of cables. Okay, so in our local networks, we have to use what? RJ45, Cat5 or Cat5e or Cat6 cables. So clear about NIC? Sorry, media. So it's all about media, guys. Any doubts on media?
Balu, one doubt here. For RJ45, 4 pair is there. No, the 4 pair is there any dimensions like how many TX and how many RX?
Yeah, Pradeep. Actually, RJ45 is a 4 pair. In RJ45 again we have different type of two type of cables which we call straight through cable, cross cable. So where we use straight through cable means cross cable is to connect the same type of devices, similar type of devices to connect. Then we use a cross cable. Like example, your PC to PC, you want to connect it. Then how do you use cross cable? PC, sorry, switch to switch. You have a switch and switch. So switch to switch you want to connect, crossover cable. Router to router you want to connect, cross cable. So similar type of devices you want to connect, you have to use what? Crossover cable. Then where we use straight cable to connect different type of devices, like PC to switch, straight cable, a switch to router, straight cable, like this. But how can I identify which is a straight cable, which is a cross cable in RJ45? RJ45 means 1, 2, 3, 4, 5, 6, 7, 8. Oh, 8 wires is there, right? 1, 2, 3. The colors which we're using in RJ45, 4 pairs, a color coding, based upon the color coding we can identify actually. LAN cables, yes, you can see here. LAN cable types, straight through cable, crossover cable, and rollover cable. So straight cable, where we straight cable, straight through cable, small office, home office networks. Straight cable categories. Just a minute. Yeah, can see clearly here. Straight-through cable, generally used for connecting two different devices of different types. Two devices of different types, like a PC to switch, switch to router, switch to firewall, and the coding, color coding is this. Like the first wire, what is the combination of wire here? Orange, white. The combination of what? Orange, white combination. The left side and right side means the cable one end, first end and second end. The left side, the first wire, what is the color combination here? Orange, white. In right side, first to place, same one, right? Orange, white. In second wire, it's completely only orange color, right? Is orange only. Second. In other side, right side is also same. Here, the combination of green, white. Here, same green, white. Blue, 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 white. Here also blue, white. Green, green, brown, white, and brown. So in one end, what are the colors I have used? In other end, the same colors if you use, then it's a straight cable. So by seeing the color coding, we can understand which is a straight cable or which is a crossover cable. But transmission and receiving is possible. First one, transmission. Second one, transmission. Third one, receiving. Sixth one is receiving. Like 1, 2, 3, and 6. Only 4 wires data transmission receiving is possible. The remaining 4 we are not using actually. So we use for power supply purpose. Okay. Crossover cable, generally used for connecting same type of devices like PC to PC, switch to switch, router to firewall, like PC to router. So similar type of devices we use what crossover cable. The crossover cable, the color coding is like this. In first place orange white in left side. In right side orange white is connected in third place. Like in left side orange, in right side is the sixth place. 3, here 1. Like cross coding actually. Rollover cable used to connecting router console port to comport, like computer comport. Like when you purchase a brand new router, how to configure it. So from your PC, connect a cable. That cable we call what? A rollover cable. This is a rollover cable. Okay. So straight cable, one end, what are the colors I have used? 1 to 1, 2 to 2, 3, 4, 5, 6, 7, 8. It's a coding of color coding. Straight cable. So is a cross cable. In other end, here it is a 1 to 3, 2 to 6, 3 to 1, 4, 5, 6 to 2, 7, 8. Says cross over cable, straight through cable, and rollover cable. Roll over one end, quite opposite. First one is here, left side is 1, here 1, 2, 3, 4. So the quite opposite, a rollover cable actually. Zeller, RJ45 cable types and color coding. Clear? Right. So these are about NIC and media. Any doubts about NIC and media? Yes, please. Any doubts, guys?
No, sir.
No, Balu.
Okay. All right. Next point, we'll start with networking devices. So networking devices are switches, no, wireless access point, router, and firewall. I'll tell you how to understand this networking devices and the study example. Let's say this is your office building. And ground floor, let's consider there are 20 devices for your administration department. The first floor, there will be 60 devices. Second floor and third floor, you have 40 devices, 40 devices. Okay. Like here, sales department, HR department, and IT department. Now my question is, in ground floor, how many devices there? 20. Let's consider all 20 devices are desktops. If all 20 devices are desktops, so generally desktops can support for what type of connectivity? I mean, desktops can support for wired connectivity or wireless connectivity, guys?
Wired connectivity, sir.
Right. So what type of devices can support for wired? These all devices we need to interconnect with switch. So we need to keep one switch in ground floor. Like what type of devices can support for wired? Your printer is supporting wired. Connect to switch. Your server supporting for wired. Connect to switch. Your desktops, your servers. Like what are the devices supporting for wired? Then all wired supporting devices are connected to switch. So switch is a hardware device which centralize the connectivity communication by using wired. Okay, guys. So all wired devices which connected to switches. Now let's consider in first floor sales department 60 devices are laptops. So laptops can support for what type of connectivity, wired or wireless?
Both wired and wireless, sir.
Both can support, right? Yeah. Now to interconnect these all wireless devices, I mean mostly we use for wireless, right? For laptops. So then here we have to use one wireless access point. Wireless access point is a hardware device which can support for wired and wireless both. Your access point can support for what? Wired and wireless, but switch is only wired connectivity. If wireless access point can support for what? Wired and wireless. Majorly in wireless, so basic in wired. Now all sales department 60 devices wirelessly they're connected to access point. Now all 60 devices can communicate. all wireless devices are sharing the data, and here all 20 devices, wired devices can communicate. But my question is how sales department and admin department can communicate? I mean, how wireless devices and wired devices can communicate? Your wireless access point can support for wide connectivity, right? So then you make one a straight cable from access point to switch. Then wireless devices and wired devices, all devices can start doing communication. So based upon what type of devices we have in your office, in your department, then we have to install access points or switches, both. So within a LAN, within a network, within an organization, we don't require here any firewall, we don't require routers. So only the two major components, two devices, which is the switches and wireless access point, guys. That's it. If the device are wireless devices, use access point. If it's a wired devices, use switches. If it's a 500 or 1000 or the 5000, whatever, depends upon your what type of devices you have actually. Like your HR department, wired, use a switch. Wired, use a switch. So very big organizations mostly use switches actually. Small organizations and hotel rooms, and there we use wireless access points. Okay. So switch is a hardware device which is centralized connectivity and communication through wired. Wireless access point is also a hardware device which is centralized connectivity and communication through wireless and wired. Now all HR department, IT department, marketing department, like admin, all departments can communicate now because of all are interconnected, right? But if requirement is your branch office, one want to communicate with your branch office two, means your traffic, your data traffic has to go with a different network. So within a LAN, within a network, then switches will do that. Within a LAN network, so you want to share any data, switches and access point can do that job actually. But now what is our task? A branch office one, HR department want to share the data to branch office two, the different network. From your mobile phone, you want to share your data to your destination device, your friend, or you may be Facebook or your YouTube, whatever, like in different location. So whenever your data traffic is reaching to different networks, that is possible with the help of routers. So router is also a hardware device which enables communication between two or more different networks. When the data traffic is going for a different network, the data traffic should go via router actually. So switch and wireless access point will work within a LAN, within organization only. But what router will do? A router will forward the traffic for different networks. Okay. If it's the same network, within a network, then router is not required. Switches is enough. Access point is enough. Okay, have connected a router. So where router is connected? A router is connected to internet, right? So when your router is connected to internet, internet is a public network. Now all attackers will come to your network. They'll send a attacks, right? Then we required one firewall. If he is firewall, and what firewall will do? Like a security job. Normally in general example, in front of office, we have a security guard will be there, right? So what is the job of security guard? When the people is coming from outside, we'll stop them and examine clearly. So ID card and permissions and timings. So examine like what he's carrying inside to the office. So what are the restrictions is it? Like the pen drives are being restricted, mouses, like these external USBs are being not allowed, you know. So this thing is being examined, is checking everything, and he is authorized or not. So these things. So similarly, what firewall will do when the traffic is coming from your attacker also, or when traffic is coming from your branch office too also. So firewall is going to stop the traffic and examine that. So which traffic is authorized and which one is a unauthorized. So firewall is going to stopping is all unauthorized traffic, is allow only authorized traffic. So simple language we can say firewall is used to filter the traffic. Is filtering network traffic actually based upon the policies, based upon the rules. That policies rules we have to define that. So clear, guys? So I hope you have a now clear idea about device that it function. Anyone, can you please repeat me where we use switch and what is the purpose of switch, and where we use wireless access point, what is the purpose of it, and what is router, what router will do, and what is firewall, what firewall do. Anyone, can you please give the answer for it?
Switches are used to connect the wired devices, whereas
Very good.
wireless access points are used to connect both wired and wireless devices.
Perfect.
Routers are used to control the traffic between different networks,
Okay.
and firewall is used to filter the network traffic based on the rules which we define.
All right. Very good. Yes. So now we have an idea about, so in your real time, what is the use of a switch and what we do with the switch and access points and routers and firewalls, right? Yeah, here we have switch. It is a hardware device that centralizes communications between wired devices connected to within a LAN. Wireless access point is also a hardware device, centralized communication between wireless and wired devices within a LAN. Switch and wireless access point will work within a LAN only. Router, it is a device which enables communication between two or more different logical networks. Okay. The next, firewall. It is a device which protects the network from unauthorized access. It can allow the traffic or denies the traffic based upon policies which we have configured in firewall. It's clear? Any doubts? See this diagram. PC number 1, PC number 2, and PC number 3. Let's consider these three PCs are desktops. Then how to centralize these three PCs? Which device is required? If three are desktops, which device is required to centralize?
Switch.
Switch.
Switch, sir.
Which is required? Cables, which type of cables is required? RJ11 or RJ45?
RJ40.
45.
RJ45. And I mean, which type of cables? As a straight cable or cross cable?
Straight as I mean, okay, this
Cable.
cross crossover because we are connecting it to switch.
Yeah, different type of devices. PC to switch. If it's PC to PC cross cable, switch to switch cross cable, router to router cross cable. So similar
I
type
think
of devices to connect cross cable, different type of device to connect what? Straight cable. So here straight
Straight.
cable, right?
Right,
Yeah.
yes.
Yes.
Yeah, okay. Now I have a printer in my office. It is supporting for wired. Take a RJ45 cable, connect to switch. Now PC1 can access printer, PC2 can access the printer, PC3 can access the printer. Like one printer is being shared to number of users because of they are in the network now, right? Okay, and I have a server, have IP phone and servers like FTP or mail server, any servers. This is also supporting for wired. I have connected to a separate switch. It's a straight cable. It's a switch A. It's a switch B. Now PC1 can access server. So PC1 can access a IP phone? No.
No.
Then how to enable communication between the PCs and servers?
Make a connection between switch to switch.
So make a
okay,
connection
yes,
between switch A and switch B. Perfect. Very good.
yes.
So just simply making one connection between switch A and switch B by using which cable?
Cross cable.
Perfect.
Cable.
Cable. So same type of devices. Switch to switch connected between cross cable. That's it. So once you make one cross cable, then PC1 you can access a printer. PC1 I can access a server. PC1 I can access another server also. Like all devices are in the part of network now. It's fine. And next requirement is a here I have a PC4, PC5, and PC6. So 4, 5, 6 devices are wireless devices. Now PC4 can communicate with the PC1? No. So PC4 can use a printer? No. So PC4 can I use a server? No. Because of these all are wired. This is wireless. Now to centralize the wireless means 4, 5, 6 devices to communicate. We require which device?
Access point.
Access point.
Access point.
Straight.
So give one access point and connect it to access point. Okay, all devices are connected to access point. So 4, 5, 6 can share the data, they can communicate. But how 4, 5, 6 users can communicate with a wide devices? PC1, PC2, 3 and servers. How?
By connecting wireless access point to switch.
That's it. Super. Like make even connection between switch B and access point because our access point can support for what? Wide and wireless both can support, right?
Yeah.
Yes. So make one straight cable from access point to switch B. Now wireless devices, wired devices, servers, printers, all are the part of a network. Now they can share the data. They can utilize the resources. So this is the same manner in the real works, like real networks also is been working connected together like this also. So this is the thing the same you have to understand real time. If you go for any IT companies, so all wired devices are connected to switches and servers are connected to switches and switch to switch connectivities and access point to switch connectivities. So this is happening. Okay, this is understand this is one branch. This is one office. Then how this PC1 user can communicate the different office, different network?
Clear router.
We require a router. So that router connect maybe connect to switch A also or switch B also or anywhere is connected. So every user means PC1 want to go to outside, the traffic should go to via router only. Like PC2 want to go to outside, so the traffic has to go via router. Means router is a gateway. The traffic you want to exit out or entrance. You want to enter the outside traffic through a router only, or you want to exit through router only. So router is a gateway for all users in the LAN. Even wireless device also, PC4 or PC5, PC6 want to go to outside. Like outside person want to access our server. So whatever the traffic, different networks traffic should go via router. Router is a gateway. So which we call default gateway actually, Right, router is okay. And then how can filter the traffic? Like how can understand, how can analyze which traffic is authorized, which traffic is unauthorized?
Firewall.
Make you one firewall. So whatever the traffic is coming from outside, what firewall will do? Stop it and examine. Are you coming from which IP address? You're going to which IP address? You are permitted. Yes, I'll allow you. If you're unauthorized, drop it. So this is a each and every device basic functioning, guys. Switches, routers, and firewalls, access point. So this is complete one small network diagram. Is it clear for everyone?
One question.
Yes, please.
From switch to router, are you gonna connect with the rollover cable?
Straight cable.
Right
Switch to
cable.
router straight cable. Rollover cable, when we use rollover cable is rollover cable only to configuration purpose. When the brand new device, so you want to provide any configuration, then we use a rollover cable. Because of switches and routers, we don't have any default configurations. So configurations, nothing is it. The device will come with empty. We need to provide the configuration. Then you have to use
Okay.
rollover cable. If it's a home-based routers, it's pre-configured. Everything is pre-configured, right?
Yeah.
So we don't require any rollover cable to configure. It's pre-configured. But it's not like a Cisco switches and routers. Nothing. We need to be configured. Then you have to use what? Rollover cable.
Okay. Okay.
Yeah.
Balu, router to firewall is a cross cable.
Router to firewall. Yes, cross cable.
Why used to say that way? Because these are on the two different networks, no?
Router, firewall, and PC. All are similar type of devices. Router to router, router to firewall, or firewall to PC, PC to router. All are similar type of devices. Okay.
So if I'm connecting my PC directly to the router, then I have to use
Cross
cross
cable.
cable.
Yes. So it's all about networking devices. Point number one, NIC, media, and next networking devices we have done. Any doubts about first 3 points to everyone I'm asking? NIC, media, networking devices. If you have any doubts, you can ask me now. Right. So next point is logical address. Logical address means IP addressing. Mr. Ashish, can you hear me? Anand, Anil, Ranjan Das, Naveen, Kamal.
Yeah, yes, Balu, we are there.
Okay. Everyone can hear me, right?
Yes.
Good. So we are starting about IP addressing session. In entire CCNA training, which is most important session is IP addressing. So I request to everyone, you please try to maintain your attention in these lessons. Okay, please concentrate. No, because we are discussing about IP address means what? Logical address. Means the logics we are going to discuss. Don't miss the logic. At least one logic if you miss, you don't understand actually. So please try to understand carefully. IP address. Is it one word or two words? Actually, here we have a two terminologies is it. One is IP, another one is address. But generally people will call it as IP address. But here we have 2 points. IP is different, address is different. So first we'll focus on address. What is address? What is the purpose of address? What is the use of address?
For identification.
Perfect. Identification. So every person we have one identification, like one address, a home address or office address, like we have an address. So address for identification purpose. If I know your address, I can identify you, I can reach you, I can trace you, I can communicate with you, right? So address for what? Identification. So similarly, within a building, within a floor, within a room, there are 20 devices. Like how each device can identify another device, or within a floor of devices, or within a building of devices. Like within a LAN, there will be 500 devices. How the device can identify another devices? Or within a WAN, wide area also. It can be local area or it can be wide area. Devices identification purpose, they require one address. That address we call what? IP address. So IP address for what? Identification a device. So these IP addresses, we have two versions. One is IP version 4 and IP version 6. Now we are working with IPv4 or IPv6. We are getting internet with IPv4, IPv6, guys. IPv4. In next coming sections, we'll be focused on IPv6. We have a separate session for that. So today we'll focus on IPv4. IPv4 is 32 bits. MAC address is how many bits MAC address, guys?
48.
48 bits, right? IPv4 is how many bits?
32.
32. Means combination of 0, 1, 1, 0, like 32 bits is required. So these 32 bits means 0 and 1. Let me take example of 32 bits combination and we'll discuss further. This is 32 bits. Just some random numbers I'm using here. 0, 0, 1, 0, 1, 0, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. One, two, three, 4, 8. Yeah. So these are 32-bit address, guys. So this is a format of binary. Those of zeros and ones, right? Now, as a user, can we understand this language? Like zeros and ones, can you remember? No. So IPv4, 32-bit address IPv4 address has been divided by 4 portions. Each portion should be contain 4, each portion we call it is a octet. I repeat, 32-bit address is divided into 4 portions. So each portion technically we call octet. Each octet should be contain 8 bits. So you understand the logics, guys. This is the logic. One of the logic is what? 32-bit address is divided into 4 portions. Each portion we call octet. So each octet should be 8 bits, like we have a 4 octets. Means how many bits? 32 bits. Okay, right. Now, first 8 bits, 1, 2, 3, 4, 8 bits. Second 8 bits, third 8 bits, fourth 8. So first octet, second octet, third octet, fourth octet. Each and every octet is being separated by using a dot. First octet, dot. Second octet, dot. Third octet, dot. So to differentiate the octets, we have used dots. Still, it is a binary language. As a user, can you understand this language? No. So we need to be convert from binary to decimal format. How to convert binary to decimal? Means 2 power 0, means 2 power n value. A 2 power n can be 0, n can be 1, n can be 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7. Why 2 power 7 up to? Because of each octet 8 bits. So first bit, second bit, 3, 4, 5 means 2 power 7 like this. So what is the value of 2 power 0? Any power 0 is 1. 2 power 1, 2, 4, 8, 16, 32, 64, 128. So first bit value is 128, 64, 32, right? 16, 8, 4, 2, 1. Okay. Now 0 indicates your bit is off. 1 indicates your bit is on. In first octet, which bit is a on bit? 32 is on, 8 is on, 2 is on. Total it 32 plus 8, 40 plus 2. So first octet value is a 42. In decimal language, we can write as what? It's a 42. Dot. Similarly, you try to calculate and tell me about second octet value, third octet value, and fourth one. Do it fast and tell me the answers.
$53.
53. Second one.
Yeah.
Okay. Are you doing, guys?
Yeah, sir.
Okay.
Third one is 25 and
Last one is 60, sir.
Good.
53.
So second octet. In second octet, which bits are on bits? 128 is off, 64 is off, 32, 16, 4, and 1. Right? 20, 30, 52, 53. So second octet value is what? 53. Like third octet, which bits are on bits? 16 is
16,
on, 8
16,
is
8,
on, and
1,
1 is on.
1,
20.
Right?
25.
25. Yeah. And last octet, which bits are on bits?
32,
32,
32, 16, 8,
8,
4.
8,
4.
4.
Yes. 32,
That
8,
would be 60.
40 plus 20, 60. It'll be 60, right? So finally, we got one IP address. 42.53.25.60 is the IP address. So this is how we can convert from binary to decimal. So there is a reason we can call IPv4 address is dotted decimal notation. Okay. This is okay, fine. How to convert from binary to decimal? Then how to convert from decimal to binary? Like example, I already have a binary number. I mean decimal number, decimal IP address is here. How can I write it in binary? 192
Divided by
dot 168 dot say 6.10 is IP address. Like how can write 192 in binary?
divide by 2.
Yeah, if you use LCM with the 2, then you can get binary, right? It's a lengthy process. Simple is what? Like if we take a table of these power values, here 128 plus 1, and 28 plus 64, how much? 128 plus
192.
64. 192. So
192.
128 is on 1 and 64 is 1. Remaining all are zeros. This is binary of 192. So 192 you can write like a 1 1 0 0 0 0 0 0 like this. Because of 128 plus 64 is a 192.
Why can't we do
Example,
like 1 0 and the remaining 32 is 1 16 1 and 8 1 and 4 1 and the next 0 0.
even dual should not come. Try to do
Sorry.
it. Yes, 128 plus 64 is a 192. Then how we can get the 192?
Yeah, if you add 32 plus 16 is 48.
Add it.
Uh,
You don't get that.
what
Will
is
be
it?
only 191.
Follow, can you repeat this 192, 168, how it is now?
Yeah, I'm repeating here. So example, if is a 10, how can write as a 10 in binary? So which two values if we add 10 will come?
8 plus 2.
8 plus
8 plus
2.
2.
So
Then all
8 is
remaining all
1,
zeros.
2 plus 1, then remaining all zeros. So you can write 1, 2, 3, 4 and 1, 0, 1, 0. This is 10. Then how we can write as a 6 in binary? Which two values if we add we can get 6?
4 plus 2.
4 plus 2.
4 plus 2 only, right? Yeah, means we can write in 6 is a 0, 0, 0, 0, 1, 1, 0. Okay. So this is how we can convert from binary to decimal and decimal to binary also. Now I'll start with the main point. How many IPv4 addresses we have? What is the starting IPv4 address? And what is the ending IPv4 address? The highest combination, the starting combination. IPv4 is 32 bits. Bits means what? 0 and 1s, right? In zeros and ones, which is a least bit? 0 is the least. Which is the highest bit? 1 is the highest. So means if you write a 32 zeros, a starting combination, starting IPv4 address. If you write 32 ones, is the last combination, right? So minimum and maximum you can get. Let me try it now. First octet least. 0, 1, 2, 3, 4, 5, 6, 7, 8. First octet list, second octet list, third octet list, and fourth octet list. So each octet being separated by using dot. First octet, second octet, and third octet. Is the least IPv4 address, guys, and highest. Highest means what? Highest is ones, right? 1, 2, 3, 4, 5, 6, 7, 8. First octet highest, second octet highest, third octet, and fourth octet. Each octet is being separated by using dot. First octet dot, second octet, third octet, and fourth octet. What is the first bit value? 128, 64, 32, 16, 8, 4, 2, 1. Here also 128, 64, 32, 16, 8, 4, 2, 1. In first octet, I mean least first octet, all are zeros, right? All are off. If it's all are off, then what is the value?
0.
0.
Value is 0. Okay. Second octet?
255.
Second, I mean least second octet?
0.
0. Least third octet?
0.
0.
Fourth octet? 0.
0.
0.
We'll come to highest. 128 plus 64 plus 32 plus 16, 8, 4, 2, 1. Because of all are on, all are ones. If you add total, what is the value?
255, sir.
255.
Perfect. 255. Second octet?
255.
Third octet?
255.
And fourth
255.
octet. So IPv4 address range is 0.0.0.0 to 255.255.255.255. In between, we have 4.3 billion combinations, 4.3 billion IP addresses. So the maximum range of IPv4 address is from any octet 0 to 255. So can you have like a 192.168.258.20? Is it valid IP address?
Yes.
Is it valid?
No.
No,
Why?
no.
258 is there, sir.
255.
So how we can get 258? It's not possible. Maximum third octet is what? 255. So maximum fourth octet is what? 255. Maximum second octet, first octet, like any octet, maximum is 255 only. So beyond the 255, we cannot use any other numbers actually. 255 is a max combination because of all ones, right? So this is a IPv4 address range. The complete range of IPv4 address is 0.0.0.0 to 255.255.255. Between we have, which is the 2 power 32 combinations. 2 power 32 combinations of IPv4 addresses, which is 4.3 billion IP addresses. Okay. Right. Now all 4.3 billion IP addresses has been classified into 5 classes. Yeah, this is the range of IPv4 address 0002 255. IP addresses are divided into 5 classes: class A, class B, C, D, E. So class A, B, C has been reserved for to use in local networks and wide networks, LAN and WAN, ABC classes. So class D IPs are reserved for multicasting. Reserved for what? Multicasting. And class E IPs are reserved for research and development. let me prepare some list of IP addresses. One 142.16.189.25 10.0.0.10 192.168.25 or 26.68 200 202 1.8 172.16.2.18 224.28.90.5 242 15 111 193.160 or 156 256.20.1. So we have some list of IP addresses. And IP addresses are divided into 5 classes, right? A, B, C. So A, B, C class are reserved for which purpose? LAN and WAN. So A, B, C classes IP addresses you have to use for your local networks and WAN networks. So class D IPs are reserved for what purpose? Multicasting purpose, like unicasting, multicasting, broadcasting. These are different type of communications. Once our routing protocols is started, then you can come to know about what is multicast and multicast addresses. You just understand, remind that class D address are reserved for what? Multicasting, okay. And class E is for research and development, R&D purpose. But here we have a list of IP addresses. Like the first one, 142.16.189.25, this IP address, for what purpose we have to use? We have to use for research and development purpose, or multicasting purpose, or we have to use on LAN and WAN? Where we have to use this IP address? We don't know, right? So when you can understand this logic is, if we know this IPs belongs to which class, then you can say answer, right? If it's a class A, is research and development, LAN and WAN. If it's a class B, is LAN and WAN. If it's a class C, LAN and WAN. If it's a class D, research and multicasting. If it's class E, research and development. So first point is we have to identify IP addresses belongs to which class. Okay. So how can understand which IPs belongs to which class? Every class will have some ranges. Based upon the range, we can understand it. Class A, class B, class C, D, and E. What is there a class A range? Anyone have idea?
0 to 125.
1
0
to 1.
to 127. Class B,
128 to 191.
128 to 191. Okay, stop here. Thank you. So here I have a small question to everyone. For class A, 0 to 127 is okay. Fine. But what is the logic behind here? 0 to 127 only. Why not some other value? Why not 0 to 20 or 0 to 100 or 0 to 110? So what is the logic we have used here? 0 to 127 only for A. For B, 128 to 191. Why 191? What is the logic here up to 191? Why not 180? Why not 200? What is the logic here? What is the logic guys here?
Octet, I mean,
So IP address classifications, ranges is being differentiated based upon the priority bits. Priority values. Priority bit is used for IP address classification. Most significant bits from first octet are selected. Class A, first octet first bit is 0. For class B, first octet first 2 bits 1 0. For class C, first octet first 3 bits 1 1 0. For class D, 1 1 1 0. Class E, 1 1 1 1. So based upon these priority bits, your address classification is done. These all priority bits are reserved from which octet? Most significant bits from first octet are selected, right? Yeah. Now I'll see, we'll use a first octet. Where is a first octet? Yeah. So first octet, least and highest I'm using, guys. Okay. First octet least. 1, 2, 3, 4, 5, 6, 7, 8. Highest ones. 1, 2, 3, 4, 5, 6, 7, 8. For class A, how many bits are being reserved for priority bits? Only 1 bit, that is 0. 0 means what? Only 1 bit. 1, 0 means 2 bits. 1, 1, 0, this is 3 bits, like this. So for class A, only 1 bit is reserved. So I'm separating that 1 bit. What is that 1 bit? 0, make them a 0 actually.
0.28.
So 0, 0. So first bit is reserved, 0 is reserved. Now I can convert into binary decimal language. All zeros, what is the value? 0. And here 128 is off. The remaining bits are on. So 64 is on, 32 is on, 16 is on, 8, 4, 2, 1. If we total it, what is the value? 127. Or simply can do 255 minus 128. You can get 127. So is the first octet 0 to 127. Second octet 0, 0, 0. Highest second octet 255 dot 255 dot 255 dot is a class A range 0002 127 255 255 255 between all our class A addresses. Is it clear, guys? We want to use one more example. Yeah, I'll explain one more example. See, just simply I'm using first octet and first octet least and highest. 2, 3, 4, 5, 6, 7, 8 and highest 1, 2, 3, 4, 5, 6, 7, 8. For class B, 2 bits are reserved. What are the 2 bits? 1, 0. Make them into 1, 0. The first 2 bits I'm making it the 1, 0 actually. 1, 0, 1, 0. That can convert into binary decimal. Binary decimal. First bit is 128. So 128. Here 64 is off. Means 255 minus 64. Can get 191. 191. So 128 to 191. For first octet, remaining octets. Least remaining octets 128.0.0.0, highest 191.255.255.255. Says class B range 128.0002 191.255.255 is a class B range. So like this, you try to calculate and tell me remaining classes and ranges. Class C range, class D range, and class E range. Do it fast. Class C 110. Class D 1110, Class E 111 is the priority bits. Do it fast.
మూడు బస్తాలు ఉన్నాయి కదా, మూడు బస్తాలు ఒకటే బస్తా ఉంది కదా, ఇంకా లేవా వేరే పెద్ద బస్తా?
Yeah. So what is the range of Class C?
23.
192 to 223, sir.
192 dot 0 dot 0
0,
dot
0,
0
0.
2
223
3.
dot 255 dot 255 dot 5.
Very good. Class D range. All right. And Class E range.
247.
240.
240.
Yes. 255 dot 255 dot 255 dot 250. These all are all classes and it ranges.
Can you tell me Class E how it will be 240?
Class E.
Yeah.
1111. 4 ones is a priority bits, right?
Yep.
Yeah, making 1, 2, 3, 4, 5, 6, 7, 8 least. 1, 2, 3, 4, 5, 6, 7, 8 highest. The 4 bits will need to be convert. Right. The 4 bits. The 4 bits. The 4 bits let me make into ones. 1, 1, 1, 1. Yeah. 128, 64, 32, 16. What is the value?
Okay, let's subtract the remaining ones. 8, 4, 12 plus 12 plus 2, 14 plus 1, 5, 15, 15 minus 2, 50. Okay, that's 240. Yep, I got it.
Yeah.
Class D 224 to
239. So now we have a clear idea about which IPs belongs to which ranges and the classes, right? Now back to our previous example. Class C, it's 2, 192 to 223, class D 224 to 239, the class E 242 255. Now in the list of addresses, so you try to tell me first IPs belongs to which class?
Class C, sir.
142. Class?
C.
My
B.
God, come on. The first
Class
octet,
B.
by saying the first
Class B.
octet, we can
Class B.
understand.
Class B, sir.
Class A only.
142.
Class
It's
B.
class
Class B.
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 Right. If it's a class B means for what purpose this IP we can use?
LAN.
LAN WAN. Right.
LAN and WAN.
Next IP address belongs to which
A.
Class A.
class? A. Next IP belongs to which class?
C.
C.
Class C.
Class
Class C.
C.
C. Right. Next IP belongs to which class?
Class C.
C.
Next address.
Class B.
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 Class B.
Next address.
Class D.
E.
Class D.
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 224
T.
D class.
D. D.
class.
Class D.
So means 224, 28, 95. This IP address for what purpose is been reserved?
Multicasting.
Multi-classing broadcast.
Can we use this IP address for LAN and WAN?
No.
No.
No. So means we cannot use this IP address for your local networks or wide networks. For your computers, we cannot use it because that is completely reserved for what? Multicasting purpose. Right. Next IPs belongs to which class?
D.
E.
42.
E.
Class E. Right.
E.
Next IPs belongs to which class?
C.
C.
No, no,
Class
no.
C.
D. D. Oh,
C.
C. C.
None.
C. Class C.
Invalid.
I
256.
256 is where?
256.
It's invalid.
Yeah.
So means you are focusing on only first octet. You are not reading the complete IP address, na? That's wrong. You need to complete read the all complete IP address. You are seeing the first octet 10. Okay, yeah. 200 is okay. See, not like that, guys. So first see, look into all the octets and find out is it valid or not first. Okay. Yeah. Is that clear for everyone?
Yes.
That's good. So now, so we got a clear understanding about just the introduction part we have done about IPv4 addresses. So how to convert from binary to decimal, decimal to binary, and IPv4 address ranges and classifications and identification of IPv4 address. Any doubts? All right, so it's all about for today, and tomorrow we'll continue with some more advanced IPv4 address logics.